right, so on our math workshop review, when is your math workshop test? Someone remind me real quick. Math workshop test, Dylan? On Friday. So please make sure that we are ready for that. It's laid out exactly like this. 20 questions on here, 20 questions on the test. All right, on the first problem, it says we need to find the area. How am I going to find the area of this rectangle? Willie?
37 times 15.
We're going to work out 37 times 15. All right, making sure that we show that work over to the side. So when we add that up, we end up with 555. If you did not, I want you to make sure that you put that 0 as a placeholder when you're multiplying by that 1. So for that area, we should get 555 when we multiply those. Hopefully we can all multiply that correctly. What has to go with that, though? Because we're talking about area, so we're measuring something. What has to go with that, Tanner? All right, feet is important, but that's not the only thing that has to be there. Chandler? Squared. All right, and remember, one way to remember that is that we did feet times feet, correct? Feet times feet means feet to the second power. Remember that exponent means you're multiplying something times itself. Now, I know we didn't multiply 15 or 37 times themselves, but both of them are measuring the same thing. So that's why we have feet squared there. Remember, our other reason is it's this entire flat surface, which is like a two-dimensional surface because it's flat. So that's 2D. So we're putting that squared because it's two-dimensional. All right, let's talk about perimeter. How am I going to find perimeter? How would I find perimeter, Alexandra?
You're going to add 15, no, plus 15, and 37 plus 37.
All right, so we're adding up both sides, not just the 15 and 37, but 15 and 15, 37 and 37. When I add that up, what do I get, Alexandra?
I got 104.
104. So adding that, we get 24, and then when we add that, we get 10. So we get 104. What has to go next to that, Alexandra? Feet. And this time, is it feet squared? No, we're not multiplying any of the feet times each other. We're just adding them up. So we just put feet. The other reason, guys, is it's just the line going around the outside. That's one-dimensional because it's just a line. It's like my stick figure. All right? So we just have 104 feet. Guys, it's going to be very important on Friday that we get that measurement correct. All right? 2 through 4. And, guys, we saw this section. Actually, it happens on the front and it happens on the back. So how important are being able to compare fractions? Like, real important. It's on 2 sections of this test because it's on 2 sections of the review. All right, so for number 2, what am I going to do in order to compare those fractions? Chandler?
You can multiply or find the common denominator.
Find the common denominator, and how am I going to do that?
Then multiply 7 times 9, and then 9 times 7.
And if I do it to the bottom of the fractions, make sure we do the same thing. To the top. So we did the 9 here and the 7 here. So what new fraction is that going to give me on my first side?
54 over 63.
63, very good. When we multiply, and then here when I multiply?
56 over 60.
And now, guys, it's really easy to compare them. So which one is going to be bigger? It's going to be the less than symbol because 6/7 is less than 8/9 because that 56 over 63 is bigger. Again, we're just going to make sure that alligator is eating the bigger fraction. On these, I've noticed like a lot of us when we've been comparing fractions, you're like, well, I can just choose the one that is closer together on the numbers. But both of these fractions are one away from each other, aren't they? Like 6 and 7 is 1 apart, 8 and 9 is 1 apart. I've had a lot of people put that these are equal. Again, remember I stated, make sure you're showing that denominator matches because that's the best way to compare them. This is going to give you that true answer every time, all right? So we do get the greater than symbol. All right, number 3. Dylan, walk me through number 3.
On the right side, simplify 4, 6.
Okay, so we can simplify 4, 6. We can do that. All right, if I simplify this, is that going to give me the same bottom number? No, so that's not going to be the same bottom number. So in this case, I probably wouldn't worry about simplifying. I would just worry about finding that common denominator. Now, you probably did find a smaller one than what I'm fixing to do, all right? But my steps, it just links in that process, so we're just going to kind of focus on keeping it as simple as we can. All right, so Dylan, how would I do that without simplifying that?
Multiply 5 by 6.
And then the top as well? And then on the other one?
Multiply 6
the top as well. All right, so Dylan, I know you didn't do it like this on your paper, but can you tell me my new fractions here? I'm going to keep that 3 as a whole number, and what's the fraction going to be?
18.
Over 30th. And then over here?
20, 30.
And you'll notice I'm keeping that whole number with them because that is important. It stays there. If you don't write it in, does it affect comparing the fractions necessarily? No, because they're the same. All right, so in this case, which fraction is bigger? 3 and 4/6. So I want to make sure that my alligator is eating the 3 and 4/6 since it's bigger. All right, Logan?
But if one fraction is less or more than one of the, mixed numbers, like for example, like 1 in 1830s and 2 in 2030s, then you have to keep the numbers, like mixed numbers.
Yeah, so if like the whole number was different, if the whole numbers are different, we don't even have to look at the fractions, and we'll see that in a minute. Or, well, on the back anyways. Alexandra?
I made them improper.
You made them improper, okay, but then when you multiplied, you had some big numbers on top, didn't you? Yeah. Still get the same answer, and that's absolutely fine, Alexandra. I wouldn't even worry about making them improper. Leave it. Since these numbers match, just worry about those fractions. All right? But again, I know you're very careful with your work. So even with those big numbers, you're taking your time and getting the right answer. Hannah? Next one? Okay, next one. Help me out.
Multiply 7 and 5 by 3.
Okay, so in this case, we're not doing 21 times 7. Why did you choose 3 here?
Because 7 will go to 21 3 times.
Okay, because 7 times 3 is 21. And then would they match on the bottom? Yeah, if I do it to the bottom, just like she said, we are going to multiply the 5 as well. All right, so what is my new fraction here? 15 over 21. And so how would those two compare? They're equal. Now there's another option. Instead of multiplying, there's something else I could have done. What is that, Zach?
You could simplify 15 over 21.
Very good. The other option, we could have divided these because 3 will go into both of those. When I divide, that would give me the 5/7. So it would still show that they match, okay? Whichever method you use, I'm fine as long as I can see those denominators match, okay? All right, let's name these shapes real quick. All right, number 5. What is the shape for number 5? Daniela. A pentagon. It has 5 sides, so that's a pentagon. All right, number 6. What is number 6? Diesel. Parallelogram. Very good. All right, and then number 7. What is number 7, Luke?
A polygon.
It is a polygon because it has multiple sides, but it has a special name. This is a special type of polygon. Locke? A trapezoid. All right, most of the time when you see a trapezoid, it's flipped the other way. So it kind of looks like it's upside down, but either way, that would be considered a trapezoid. All right. Number 8, guys, in my opinion, number 8 is the hardest, it's the trickiest problem on this review, which means number 8 on your test might be the trickiest problem. So let's make sure we pay close attention to number 8 as we go over it. All right, it says Morgan's partial solution to the division problem is below. So they started working the problem, haven't gotten very far, it doesn't look like, all right? Mark asked Morgan why he put the 2 on top of the 6 and not above the 8. Which one of the following could be Morgan's answer? So we got there are 2 whole number multiples of 34 and 36, but 2 can go over either 8 or 6. Can 2, it says placement does not matter. Guys, does placement not matter? No, guys, we know placement is a big deal, so we know A is not a choice. So let's mark that one out. All right, number B says same thing, 2 whole number factors of 34 and 86, but 2 can go over either the 8 or 6 because placement does not matter. Does placement matter? So we know our answer is not B. So we've been able to eliminate 2 of them very easily. All right, so now we've got to decide between C and D. So the big question here is 2 over the 6 because there are 2 factors of 34 in the number 86, or is 2 placed over the 6 because there are 2 multiples of 34 in the number 86? Which is going to be my best option there? Mateo? D. There are 2 multiples. Now, what makes you say multiples and not factors, Mateo?
Because multiples are when it's, multiplying.
Well, when it's multiplying.
34 times 2. So that would be the correct one, because if there are 2 whole number factors, then that means, that doesn't even really make sense.
All right, yeah, so I like what it's saying. Like when it's saying 2 whole number factors of 34, doesn't really make sense because 2 whole number factors of 34, that makes me think like 34 times 34. Is that what we're saying happens with 86? No, we're saying that there are 2 multiples of 34 because 34 will go in there multiple times. How many times does it actually go? Twice because of that multiplication. Very good, Mateo. So D is the best choice. All right, guys, are there any questions? I know number 8 was the wording was kind of confusing. Hopefully we were all able to get it down to either C or D. All right, everyone should have been able to get down to there. Are there any questions on why we're choosing D and not C? And my folks that just came in, we're looking at the math workshop review from yesterday, okay? Are there any questions on why it was D? All right, guys, please remember we're going to see this problem tomorrow. Not tomorrow, but Friday. Remember, guys, I will not see your class tomorrow, but the math workshop test is on Friday. All right, let's look on the back. All right, number 9. A square is always a rectangle. True or false? A square is always a rectangle. Logan.
False.
True. All right, this one a lot of people have asked questions about. So let's kind of talk about this. Guys, a rectangle is a shape that has 4 sides and all the sides form right angles. Is that true for a square? Yeah. The only difference is does a rectangle have to be equal on all the sides? No, a rectangle could have like long sides. A rectangle could have, short sides. It could have long sides. So these are our typical rectangles where they have 4 sides all with right angles. All right. A square is just a special one where the sides are also equal to each other. This is a rectangle. It's just a special rectangle. All right. So yes, a square is a rectangle. Now here's a question. Is a rectangle always a square? No. But a square is technically classified as a rectangle. It's kind of like every single shape that has 4 sides is a quadrilateral, right? But do we call all of them quadrilaterals? No. Would I call this a quadrilateral? It is, but what's the special name for it? A rectangle. Just like this is a rectangle, but it's also known as a square because it's special. It has all those equal sides, all right? All right, number 10, a quadrilateral is always a rhombus. No, we just said that this is a quadrilateral. Is this a rhombus? No, so this is definitely false. All right. All rectangles are also parallelograms. Dylan? True. A parallelogram, remember, that means my top and bottom are parallel, and my sides are parallel. That's going to be true for every rectangle because of those right angles. Every one of them, our sides are going to go in the same direction, and the top and bottom are going to go in the same direction. All right, so number 11 is true. All right. Number 12, I've seen some people have trouble with 12. I think what confused people about 12 is they did not realize number 12, that's just this piece right here. This is number 12. Some people kept trying to make this go with 12. It doesn't, all right? Yeah. All it's asking you, it says Stacy's partial solution to her homework problem. Like, this is how far she's worked it. And it says, what operation should Stacy do next? It's just asking you to name. What's the next step here? What are we going to do next here, Logan?
Multiply.
We're going to multiply. I've had a lot of people here say subtract. Is there anyone that put subtract? All right, a couple of us. Guys, thank you for being honest. All right, so guys, if I were going to subtract, is there a number underneath 77 to subtract? No, so we can't do subtraction. I need to multiply 3 times 21 to find the number that goes here so that I can subtract. But before I can do that, I have to multiply those two, okay? Questions about number 12? All right, so y'all can see where that 7, y'all see where she brought that down, right? She said 21 goes into 77 3 times, and now we're ready to multiply that. What I would do, guys, is you could work it out on your own here. Once you write that 77, ask yourself, what am I doing? What am I doing there? All right, questions about number 12? Okay. Number 13. 13, what am I going to do to work out number 13? What's the rule? What's my rule to work out 13? Tanner?
Line up the decimals.
Line up the decimals. So I have 2.3 and 67.2. And you can see my decimals are in a straight line. What do I get when I add that together? Chandler? 69.5. And this one was nice and easy. Nothing carried. It's pretty straightforward. All right. Number 14. Number 14. How am I going to work that one out? Zach?
First, you put 210.8 here.
Okay. And then on the bottom?
You put 209.64.
All right, and I didn't write it exactly like Zach was telling me because he added that 0. I just wanted to make sure, remember that 4 doesn't have anything on top, so I am going to add that 0 now that Zach mentioned. Just want to make sure we know why it's there, okay? So now I'm ready to subtract. Can I do 0 minus 4? No, so I'm going to change my 8 to a 7. 0 becomes 10. 10 minus 4? 6. 7 minus 6? 1. Keep my decimal. Can I do 0 minus 9? No, so I'm going to borrow. 1 becomes? 0 becomes? 10. So now it says 10 minus 9, which is? 1. 0 minus 0. 2 minus 2. 0. So my answer is just going to be 1.16. All right, if you left those extra zeros in front, do I want them in my final answer? No. If they're in the front of a whole number, they're just extra. Like I wouldn't say 001. I would just say the number 1. All right. Kenna? As long as they're not included in the box, that's fine. All right, number 15. Number 15. When I set this up, do I need to worry about lining those decimals up? No, I'm just lining up my numbers, all right? So 4 times 1, 4. 4 times 2, 8. 4 times 6, 24. Remember, put your 0 as a placeholder. Now we're going to do 3. 3 times 1, 3. 3 times 2, 3 times 6, 18. And now we're ready to add that up. 4 plus 0, 8 plus 3, 11. Carry the 1. 4 and 6 is 10 plus that 1, 11. 2 and 8 is 10 plus that 1, 11. And 1 and 1 is 2. Now, how do I decide where my decimal is going to go? Anyone new? Anyone new that I haven't called on? Sarah Page. 3 times because there are 3 numbers after the decimal in my problem. 1, 2, 3. So we're going to go 1, 2, 3 over and then put our decimal. Very good, Sarah Page. All right. Number 16. We're dividing. Setting that up. How am I setting that up? Taylor, what number is going to go out the door? Taylor Robertson? 2. Mm-hmm. Well, 0.02 for now. And then what's going in the house, Taylor? 2.04. So now, Taylor, obviously you've already changed it. What's wrong with this problem right now? Excellent. We can't have a decimal at the door, so it goes over twice. And if I do it at the door? Do it in the house. And make sure you raise it to the roof. All right, guys, please double check right now in your work. Did you move your decimal correctly? All right, so now we're ready to divide. 2 will go into 2. 1, which gives me 2. When I subtract, I get 0. Guys, please remember, if you have a number, like I brought down 0, I have to divide. How many times will 2 go into 0? 0 times 2. 0, I subtract, I get 0. Bring down the 4. 2 will go into 4. 2 times 4. When I subtract, I get 0. Is there anything left to bring down? No. Did I have a remainder? No. So we're good. My answer is just 102. All right. Last part, comparing those fractions. Comparing those fractions on 17. 17, what's a good denominator for those two? Grace? 28. So I'm going to multiply the first ones by 7 and the second ones by 4. 3 times 7 is 21 over 4 times 7? 28. On the top, 6 times 4. On the bottom, 7 times 4. Now do my denominators match? Yes, so now I can compare them. Which one's bigger, 21 over 28 or 24 over 28? 24, so I'm going to show that that side, the 6/7, is the one the alligator wants to eat because it is bigger. All right, number 18. Now, number 18 is a little bit different. How can I work out number 18? Because I've got an improper and I have a mixed number. So what could I do here? What could I do to work this one out? Willie?
Divide 23 by 7.
Let's divide this. Let's actually make this a mixed number. So how many times will 7 go into 23, Willie? 3 times with how many left over? 2. So 7 goes into 23 3 times, which is 21. So we still have 2 left over. So now I have 3 and 2 7s. Those already have the same denominator, don't they? So now it's a lot easier to compare these. So I have 3 and 2 7s versus 3 and 3 7s. Which one of those is bigger? The 3 and 3 7s, right? All right. Last period, someone else has said they changed this to improper. As long as you make them in the same form, that's fine. They either need to both be improper or they need to both be mixed numbers. All right, number 19. 1 and 1/9 versus 2 and 1/9. They both say 1/9. Does that mean that they're going to be equal here? Dylan?
Yeah, they're going to be, one's going to be, 1 and 1/9 is going to be less than 2 and 1/9.
Why?
Because 2 is a bigger number.
2 is bigger. Do I even need to look at the fraction here?
No.
No, that 2 is automatically going to be bigger. What if this said 2 and 7/9? I'm sorry. I changed the wrong one, didn't I? What if this said 1 and 8/9 versus 2 and 7/9? Which one's bigger? It's still going to be the 2 because that whole number is bigger. All right, even if I change the fractions, it doesn't matter if that whole number is bigger. All right, last one. What am I going to do to compare this one? Diesel. Very good. So we're going to divide these both by 2, because what is 14 divided by 2? 7. And then would that bottom number match? And then 6 divided by 2 is 3. So how are these going to compare, Diesel? They're equal. All right. What if I didn't divide? What would be my other option? My other option, Grace? I could have multiplied this side by 2, and they would have matched as well. All right? Are there any questions about that? All right, guys, please remember, if you can work these and you feel confident about these problems, then you're ready for your math workshop test.